Okay, so welcome everyone. This week's webinar will cover how to use our newest coding model, SCX Coder, to dramatically reduce your Claude or Codex or any frontier model build. And we'll do a live demo at the end so we can see how it works in action. So SCX Coder isn't really positioned like a typical model. The idea is that it behaves more like an engineer that's part of your team. Instead of just answering a prompt once, it can break a task down, work through it step by step, write code across multiple files, and then come back and improve what it did. So the shift here is from one-shot responses to something that actually executes workflows, which is what people are trying to do with agents today. The reason this matters is because agent-style coding actually works, but it gets expensive really fast. If you're using something like Claude or GPT for everything, the cost just keeps stacking up. So our approach is pretty simple. You don't need the most expensive model for every part of the job. Use some models for high-level thinking, and then you offload the bulk of the execution to something much more efficient, but just as effective. And that's where most of the cost savings come from. And obviously, the first reaction to this is, okay, what's the actual trade-off? But from our internal benchmarks, SCX Coder is pretty close to the top proprietary models on coding tasks. In some cases, it's a little bit behind, and in other cases, it's actually ahead, especially on more complex or multi-step evaluations. So it's not like you're dropping way down in quality, you're staying in the same range, but changing the cost structure in your favor. The other big piece is speed. Our infrastructure is built for really high throughput, so you're getting responses several times faster than what you'd normally see from a proprietary API. That's partly because of how we run the models, including more specialized hardware setups instead of just standard GPU pipelines. In practice, it just means things feel more responsive and agents can move a lot quicker. And the way this is meant to be used isn't replacing something like Claude completely, although you can definitely do that. It's more of a hybrid setup. So you use a high-end model when you need strong reasoning or planning, and then you hand off the actual execution and iteration to SCX Coder. So instead of one model doing everything, you're splitting the workload in a way that's a lot more efficient. And this is where it becomes really obvious why you'd want to do that. SCX Coder is dramatically cheaper. When you compare it to models like GPT 5.4 or Claude Opus, you're looking at something like 10 to 20 times cheaper depending on the use case. So once you scale up usage, that difference becomes pretty hard to ignore. If you have a couple hundred engineers all using something like Claude for coding, you might be spending around 4 million a year. If you introduce this routing approach and shift a lot of the execution work to SCX, that drops to a little over 2 million. So you're saving close to half without really changing how the team works. This becomes even more important when you think about agents like OpenClaw. Agents don't just run once, they explore options, they retry things, branch out, and iterate. That means they burn through a lot of tokens. And if your costs are high, you end up limiting how much they can actually do. If it's cheap and fast, you can let them run more freely, which usually leads to better results. So just wanted to zoom out a bit and explain that we're building out the full infrastructure so companies can run AI workloads in their own environment with full control over data and compliance. And that's especially relevant for industries where data can't leave a region or can't be sent to a third-party provider. So the broader vision here is not just cheaper AI, but more controlled and scalable AI. And that's basically the idea. So for SCX Coder, keep performance close to the top models, make it much cheaper, make it faster, and structure it in a way that actually works for real workflows. So now we can take a look at what this actually looks like in practice. You can go ahead and look at the public GitHub repo to see how to set up your open code so it works with SCX Coder. Once you sign up for SCX.ai, you can get your API key, and then the process is really straightforward. Just go to github.com/southerncrossai/SCX-coder-demo, and it'll tell you how to register your SCX AI API key with OpenCode, and then how to set it up so you can do planning with something like Opus 4.7 or GPT 5.4, and then do the actual execution with SCX Coder. So I'll stop sharing here, and then we'll go through a live build right now. Okay, got to share the entire screen. Okay, so we'll just do a quick demo here. In OpenCode, once you get into OpenCode and you've set it up according to how the instructions explain it on GitHub, you'll be able to use the tab button to switch between planning and build mode. And here you can see that in planning mode, we have Opus 4.7. And in build mode, we have SCX Coder. So for example, we can start with planning. We can do a simple polling app. That's the classic example. So build a polling app. And then we could say use vanilla JS, HTML, and CSS, just to keep it simple. So we'll let Opus 4.7 plan out this app, but not actually build anything yet. So it's going to ask me some questions. Where should polls and votes be stored? Let's just do local storage only. Features. Sure. Create poll with N options. Vote once per poll. Live results. Sure. And we could stick to those. UI style, clean, minimal. Okay, we'll confirm this. And I'll just hit tab right now to switch to SCX Coder. So when it's done planning, we could just say build it. And it will execute the plan and save you on the costs. And by the way, if you see this context here and the spend, that's actually not accurate for OpenCode. It would be a lot less than this. I think this is just some default value. So let's wait until this finishes, and then I'll stop sharing and then share the finished app so we can take a look. Okay, so this is done. Let's go ahead and open it up. Okay. So everyone should see the polling app right now. Super basic. But again, we did the planning with Opus 4.7, and then we did the actual execution with SCX Coder. And let's choose our favorite programming language, Python, of course, or although actually it might be Rust now. Click vote, and that's it. Okay, guys, just to remind you what the GitHub URL is, it's github.com/southerncrossai/SCX-coder-demo. And I'm sure we'll include that somewhere else as well, so people could just click that and follow the instructions on how to add SCX Coder to your OpenCode instance. Now we can go to questions. So if anyone has any questions, please post them here. Okay. So I see Sam asks, is SCX Coder implementation quicker than Claude? Yes, especially if you're doing this from Australia. I'm currently in the US, but if you're doing it from Australia, it's going to be a lot quicker than Opus 4.7. Ash says, great tool. Can I use a harness with this? Of course. And then Mark says, how can this fit into the development cycle? So SCX API is open AI compatible API. So the schema works pretty much in anything that supports open AI models. So it doesn't have to be open code. It could be Codex or which is open source, or Cursor, or anything that you prefer, or you could set it for OpenClaw, since it accepts any OpenAI compatible API. Any more questions? Okay, let's wrap this up. Thanks, guys. Thanks, everyone.